Okay, so this is, what year is this? 2013? Question 1. So here's the problem. We have our little anchor, we have our little boat. They give us a lot of info, right? So first of all, let's draw the free body on this. So we have gravity coming down, Fg. What else do we have? Buoyancy force going up, F sub B, and the tension in the rope. Oops. All right, F sub T. Those three, that's it. Basically 3 points, 1 for each. Okay? Look, you almost got a 3 if you got that one right. Letter B, calculate the magnitude of the buoyancy force. If you need to draw anything else, do not write it back on. So this is an important concept. Once you've kind of given your answer for your FBD, don't go back to it to do future work. Like if you need the FBD again, don't go back up to it. And this is especially true for ones where you're pulling at an angle, so maybe your FBD looks like this or something, right? Don't go back onto your FBD and start resolving the angles, because then if it looks like this, they're not going to give you full credit when they grade that. Okay, so keep that in mind as you're doing these problems. So anyway, this one I don't even think you need to do that. So FB equals, what's the equation? Rho GV. And I believe they give that all to you, right? Yeah. So it's not even, they don't even try to trick you. So there you go, Rho GV. Substitute in the numbers. See, how much was this worth? This was worth 3 points. There you go. No, 2 points, sorry. Alright, so FB equals, I'll just do it. So 1,000 times 6.25 times 10 to the negative third times 9.8 equals 61.3. Okay, what's the units? Newtons. So this is worth 2 points, basically 1 for this and 1 for the answer. Okay, letter C. Calculate the tension in the rope. Again, do not go back and fix it. Yeah?
For 9.8, what if you use 10?
That's okay. If you use 10, you got, what, 62.5 or something? It says here that it's okay if you use 10. I would say in general, when you have your calculator, go ahead and use 9.8. One of the things I do want to point out is this for a correct answer with units. So make sure you're putting the units. What they've been doing a lot lately is if you don't put the units, you only get the work credit. So make sure you're putting the units down. Okay? All right, letter C, calculate the tension in the rope. So this one, we just go back to your free body, right? So your free body looks like this. So you just say, well, FB plus FT minus FG should equal MA, which equals 0 because it's in equilibrium. So that should be essentially your setup. What are we solving for? Tension. So FT should equal FG minus FB. So mg, what was m? 50 grams or kilograms? Times 9.8 minus whatever you got there, 61.3. Okay, tension looks like it's 429. Okay, 1, 2, 3. Okay, so that's what do we add? 8 points? 6, 7, 8? Anyone got 8 points already?
Yes.
Wow. Okay, so you're getting a 5, right? Everyone's getting a 5.
Can they all be like this?
Letter D, the bottom of the boat is at a depth of D below the surface. Suppose the anchor is lifted back into the boat so that the boat has a new depth below the surface. How does D prime compare to D? Okay, so the concept of this, here's our boat initially. We have our little anchor here, right? This is D. Now we're going to put the anchor into the boat. what happens? Does it sink further? Does it stay the same? Or does it become shallower? Sinks further, yeah. So this is going to sink further. So this is d prime. So you would say d prime is greater than d. That's the answer. 1 point if you said that. And then your explanation, basically when this is in the water, there's a buoyancy force on the anchor itself, right? Compensating with the weight. When you put the anchor into the boat, there's no buoyancy on the anchor, so you need to increase the buoyancy on the boat itself. So for that to happen, more of the volume of the boat needs to sink, needs to be underneath the water. So that's kind of the explanation that you would give, something along the lines. Here's what they said. When the anchor is lifted onto the boat, the buoyant force on the boat must now support the weight of both the boat and the anchor. This will increase the buoyant force, which requires a greater volume of water, which means the boat will reach a greater depth into the water. So some kind of explanation along those lines. Yeah?
When you said that by putting the anchor in the boat, you increase the density of the boat, and then the amount of volume submerged in water is the density of the object divided by the density.
That's a good question. I don't know if they would give you credit for that. If I were grading it, I would not give you credit for that, because the density of the boat itself is not changed. If you said something like, yeah, I wouldn't use that, because density is a very specific meaning to the boat, the structure of the boat itself. And so yeah, I would say I wouldn't give you credit, but they might.
Does the mass increase and the density increase then?
No, that's what it says with the actual focus. Just like.
Yeah, I mean the overall, density of the problem, if you think of it in terms of mass over volume, that's the problem with sometimes thinking of things in terms of equations, because yeah, the equation says it does, but that's not really what density means.